Have you ever seen a router on a stick? I know some of you might be thinking about maybe a barbecue fish or a suya on a stick. Believe me, far from that. Router on a stick or intervenor route is one of my favorite topic. I usually like to talk or discuss about, and is the topic that we'll be looking into in our today's class in network pips. So if you remember in our previous video, we said that devices on the same VLAN or the same domain can communicate with one another, right? But devices on a separate VLAN cannot communicate with one another. So which means if I have this PC here on this, for example, let me say this is a VLAN 10, they can communicate with one another, but they cannot communicate with PCs on this VLAN, let me say VLAN 20, right? So that's what it is. So but by default, let me put that by default, so this device can communicate to this device, but they cannot communicate with this guy by default. So there might be a need for this device on separate VLANs, devices on separate VLANs to communicate with one another. So we might have a server seated over here on our network, and they have another server maybe seated over here in this other VLAN. So requirements from our maybe system admin or developer, they might have a requirement to enable these two servers seated on these separate VLANs to communicate with one another. And they also, you might have maybe users on different departments that are located on different VLANs. So maybe this guy might be finance user, finance department. People that are sitting here maybe might be the HR department or something like that. I know that HR and finance usually have some things to interface or some files to share with each other or something like that. So needs might come up for them to communicate, and they share files with one another. And this might not always be the case for all the departments or VLANs on your network to communicate with one another. You just some specific VLANs based on the requirements. So that's where intervenor routing comes in. So intervenor routing enables devices or hosts on different VLANs to communicate with one another. So this is also known as router on a stick. So how did they coin that name, router on a stick? So router on a stick simply means that the router interface, so let me say this is the router, you understand? The router interface, which is this, is going to have one physical router interface, I mean to say, is going to have multiple virtual interface. So let me say these guys, okay, let me use another color to draw these guys. So let me say this guy is on VLAN 10, for example, and this guy is on VLAN 20. You understand? So this one physical router interface, now they are seeing here this one big router physical interface that is connected to this switch. You understand? It's going to have multiple virtual interface, so which means it's going to have a virtual interface of VLAN 10. It's going to have a virtual interface of VLAN of VLAN 20 as well. It's going to convey these two traffic of these different VLANs separately on his virtual interface. So that's what router on a stick means. So one physical interface of the router communicating with conveying multiple VLAN traffic at the same time. So enough of the discussion. Let's see how this actually works. So like as usual, I've taken my time to preset this network for you. So I've already assigned IP addresses to these devices, and they also that's the pre setup I did. So we are taking this big network that you are seeing here now, this 192.168.1.0/24, by that we have up to like 254 valid host address on this network. If you remember in our subnetting video, if you have not watched that, please go back and watch it. So we're going to break that network into 2 because we have a requirement of 2 units. We have our, let me say this is our finance department and this is our HR. So the finance department is on VLAN 10 and the HR is on VLAN 20, and we have two requirements, two separate network. I'm going to break this network into 2. So if I'm to break into 2, remember we borrow 1 bit, you understand, and they divide it. We're going to divide it into 2, and later on our subnet mask is going to be /25, and /25 subnet mask is going to be 255.255.255.128. So I'm going to assign the first valid address of this first network I broke down to my router, to one of my virtual router interface, which will be the default gateway of this host. I'm going to give the second valid host address to this host as well. So that's what I just did here now. So the same thing goes to this other PC now. If I come here, if I go here now, you're going to see this network was divided into 2, and the first valid host on this other part of this, the second part of the network, is 129, which was given to my router virtual interface, you understand, and the 130, which is the second valid host, to this host as well. I was given to this host. So why did I need a default gateway here? Now remember, default gateway enables me to communicate out of my local network. So for me to be able to communicate to this other guy, I'll need, that is on a separate network, I'll need a default gateway. That's why I assigned this default gateway. So I'm going to close this now and then do my configuration. So the first configuration I'm going to do will be on this router. So I'm going to go to, on this switch, go to this switch. I'm going to draw this here now. Ignore this other diagram on the left, on the right, let's see. So I'm going to enter this enable config T. Now the first interface I want to go into is my F0/2, which is connected to PC2 on VLAN 10. I'm going to go to interface F0/2. No, F0/2. So I'm going to do switch ports, access VLAN 10. Oh, that's VLAN 10. So I'm going to go, so you can see the interface went down and it's coming up. I'm going to go to the second interface, which is F0/3. Then switch ports, access VLAN 20. Then now is it, that's all. I've already assigned my 2 hosts to their VLAN. Let me verify that. Do show VLAN. So you can see my VLAN. So this guy is on this. I'm going to remove this VLAN 19. If I want to remove it, I simply then put the command no VLAN 19. Remember, if you want to remove any command, you put no in front of that command, VLAN 19, and it's no longer there again. Do show VLAN. You can see VLAN 19 is no longer there again. So I'm going to have only 10 and 20 as my valid VLAN, and they are assigned to the interface. So what will happen on this F0/1 that is connected to the router is that I'm going to trunk that interface, remember, to convey multiple VLAN traffic to this router. So to enable the router to now route traffic to the separate VLANs. So I'm going to go to that F0/1. Remember, you are still seeing it here, which is not trunked. So I'm going to expand this. You are still seeing it here, which means that interface is not trunk. And if I do show interface trunk, you can see it's not showing me any trunk interface. I'm going to go to that interface F0/1 and do switch ports mode trunk. That's all. I've trunked that interface. Do show VLAN. Okay, you're still seeing it there because it's still coming up. So if you give it some time, it will come up. So you can bring up, do it again. It's still coming up. Okay, that interface is down because the other end of the device which that is connected to is down. So a router interface by default is going to be down, which is this guy. So if I go to this router interface now, G0/0, and bring it up now, this interface is going to automatically trunk. So I'm going to go to this router interface and bring it up. So you can see what I mean. No, enter config T. Config T interface G0/0, right? Let me show you. Do show IP interface brief to show you that interface is down by default. You can see administratively down, so which means I'm going to bring it up by issuing a no shutdown command to bring up that interface. I'm going to do no shutdown to bring up that interface. So that interface is going to go up and come down. It's going to go down and come up, I mean to say. So you can see my switch is already negotiating to become a trunk with this guy. So I'm going to on this interface we're not going to assign an IP address. So to make sure that it's no IP address assigned to this interface, though I know that it's no IP address, I'm going to do no IP add to make sure there is no IP address assigned to it. Then exit from that interface. So let me show you my switch now to check if it has trunked. So you show VLAN, you can see you're no longer seeing that F0/1 on that interface. Now if I do show interface trunk, you can see it's now trunking. So it's now permitting all VLANs by default. So if you want to prove me to know how to do it, if you have not watched that, watch our previous video. Then encapsulation A0.1Q is trunking, you understand? So that's all. So let me go back to my router and finish up this configuration. So on this router, you're not going to assign any IP address on this physical interface. Rather, we're going to assign it on the virtual interface of that router. So how are we going to do that? We're going to go into that interface G0/0 G0/0 I think is 0. Abi? Yeah. Let me verify. Do show IP interface brief. G0/0/0. Yeah. So interface G0/0/0. Now you're not going to enter this interface like this. You're going to put dot. You understand? Let me do a question mark. You can see I have up to 4 billion virtual interface that I can create. So I can give it any name, I can give it any dot anything, maybe .100 dot this thing, but just for administrative purpose I want to give this interface .10. So I will know that this .10 is for VLAN 10. It does not necessarily need to match. You understand? So I'm just going to give it VLAN .10. So I can see my prompt have changed to sub interface. You understand? So the first thing I'm going to do is to state the encapsulation protocol of this trunk virtual interface now. So before assigning my IP address to it, so I'm going to do encapsulation .1Q. Then it's going to ask you which VLAN does that interface belong to. This I want it to belong to VLAN 10. You understand? Then you now go ahead and assign that IP address which I showed you earlier, the default gateway 192.168.1.1, then 255.255.255.128. That's all. I'm going to exit, then go to the second virtual interface of this guy, G0/0.20. Remember, it must not necessarily be .20. You understand? Then encapsulation .1Q. I want this guy to belong to .20. It must match with the VLAN ID of where you want it to match to. So I want it to be .20 on, want it to be on VLAN 20. So .20, then IP address. No, it's not. Yeah, .20. Yeah. Then IP address 192.168.129. Right? .1.129. .129, then 255.255.255.128. Yeah, Then if I verify my interface, do show IP interface brief, you can now see I have two virtual interfaces now. You can see, and they are both up. You understand? And that's all. If I show my routing table, let me say do show IP routes. It's going to show me all the routes that this router knows. So you can see also this router knows about these guys are directly connected to it, of course. So that's all about it. If I go to this PC now, for example, and I decide to ping this guy, ping 192.168.1.120, no, .130. That's the IP address of the other host. What do you think will happen? First timeout, then reply. Yeah, it's replying. So that's it, sir. That's all about Intervenor routing, so this for router on a stick. So but you guys should be wondering about what was this architecture from here again. So we can also achieve this same task that we just did here now with our layer 2 device, our multi-layer switch. I mean to say our layer 3 switch. You can call it multi-layer switch, or you can call it layer 3 switch. So layer 3 switch does the same, has a switching capability, and also have an extra feature which enables this switch to do routing as well. So you can also achieve this with this guy. So I'm going to go ahead and want to remove this default gate. I want to show you something if I do that. So yeah, so I'm going to go ahead and configure this device, configure this router on a stick. I've already pre-configured that. I just removed the default gateway of this guy to show you that without this default gateway, this guy cannot communicate to this guy. So I'm going to go here, go to my CLI, open here. So to set up my switch, no, I don't want to enter setup mode, enter config T. Then interface, which VLAN interface is this guy connected to. So this PC that is on VLAN 10 is connected to F0/1. This guy right there is connected to F0/2. So I'm going to go to my F0/1, then switch port, access VLAN 10. Yeah, that's all. Then go to interface F0/2, switch ports, access VLAN 20. That's all. Then one more thing is, now I've already assigned the interface on that switch to the specified VLAN. So another thing now to do now is to configure what they call your switch virtual interface. So switch virtual interface is where we are now going to now assign the IP address that is allocated to each VLAN. So going to do that, you're going to use the command interface VLAN 10. So you're going to go to the switch virtual interface of this VLAN 10 and assign an IP address that is on that VLAN 10. So I'm going to give you the default gateway of that switch, which is IP address 192.168.1.1, right? Then 255.255.128. Yeah. Then go to the other one, interface VLAN 20, IP address 192.168.1.129, and 255.255.128. Yeah, and that's all. So I don't know, you guys were like, oh, why did I show you this? Why did I show you this one earlier? I know. So let's see if they can communicate with one another. So 192.168.1.130, right? So it's going to send the first message and app for timeout. Timeout. So why is it not working? So you know why? Because I did not assign a default gateway to this guy. Remember, I removed that default gateway, so I'm going to put it back. So I'm going to do 192.168.1.1. So I'm going to put that default gateway back, and let's try this again to see if it's going to work. Timeouts. Timeout. It's still timing out. So what are we not getting right? So you know why? This guy over here, this switch is still just a normal switch. You understand? We have not enabled the routing capability in it. So for us to do that, we have to go and just enable that routing capability. On the global configuration mode, you simply dial just one simple command, just IP routing. That's all. So it's that easy, right? So you just come here and let's try that. Let's try this again. Come on, timeout, and it's replying. So the first packet that just timeout is as a result of pack of app. It's asking for, oh, who is 192.168.130. You understand? The guy will now reply with his mark out, this kind of stuff, and yeah, no. So that's how it is, man. So it's very easy. You understand? So the verification command here, you can also do show, or let me just come down to this enable mode and show you. So show IP route. You're going to see the interface, and you can also use show run, which is one of my favorite command I can also always use to verify all the configurations that we have done on this network. Show run, you can see I assigned a switch virtual interface on this guy. You'll be seeing all the configuration that you have done on this switch as well. And you can see when you issued show IP routing as well. And if you scroll up, you're going to see that command. I think it's on the top. Yeah, see it here. One of the first command you're going to see, IP route. So that's all about intervenor routing and the route on the stick, and they also using layer 3 or multi-layer switch to achieve this. I would like to thank you for watching this video. Please don't forget to subscribe and like this video. Thank you for watching. See you in the next video.